Hello everyone, this is grade 6, module 5, lesson 7 problem set. The first question states, given the pairs of points, determine whether the segment that joins them is horizontal, vertical, or neither. So we're looking at x and y, and we want to see if any of the points are the same. And I see that the 5, or the y coordinate, is the same. So when the y is the same, it's going to be a horizontal line. And when the x is the same, it's going to be a vertical. Now, the thing that we need to remember is I'm not talking about this x and this y, I'm talking about the coordinates. So the 3 is an x coordinate, the 5 is a y coordinate. The -2 is an x coordinate, the 5 is a y. So they have the same y, which means it's a horizontal. Now for the next one, we're going to look at these and see I got -4, 9, and then 4, -9. They don't have anything that are the exact same coordinate, meaning I look at the x as -4 and a 4, and the y is 9 and -9. They're not the same, so they're going to be neither. They aren't going to be horizontal or vertical, they're going to be a diagonal. So let's take a look at C. And I have a -7 for my x and a 1 for my y. I have a -7 for my x and a 4 for my y. So it looks like the x's are the same. And if the x is the same, then it's a vertical line. Another good way to test this out is to actually plot these points and connect them on a coordinate plane or a grid and see what they make. And you'll see that anytime that the x coordinates are the same, they're going to be a vertical line. And anytime the y coordinates are the same, it's going to be horizontal. So we'll take a look at 2. And here's where we're going to find distance, but we're also going to have to prove this using absolute value. And there's a couple things we need to keep in mind. When the points, we're looking for similarities here. So -3, 5, 7, 5. I see that the 5s are the same. So I'm going to focus on the ones that aren't the same. I have a 7 and a -3. And we're looking for if they're on opposite sides of 0. Then that means we're going to add. If they're the same side of 0, we subtract. Meaning if they have the same sign, we subtract them. If they're both positive or they're both negative, we're going to subtract the 2. If they're one positive and one negative, then we're going to add the 2. But it's not just adding the 2. We have to find the absolute values first. So let's take those two numbers that we're looking at, and we're looking at the -3. We need the absolute value, and we have a 7, which is the absolute value we're trying to find. And what we need to do is, since they're on opposite sides of 0, I have a negative and a positive, I'm going to add the 2. I know the absolute value of -3 is 3, and the absolute value of 7 is 7. So 3 plus 7 is 10. And absolute value is just saying how many spaces away from 0 are they? And they're going to always be positive. So we have 10. So the distance is 10, meaning how long is this line segment? So let's take a look at the next one. And I'm going to match up again, and I see that I have a -3 and a -3. So I'm going to look at the x coordinate, and I have a 1 and a -6, and I'm going to find the absolute values of them. Now, if they have different signs, meaning I have one positive and one negative, they're on opposite sides of 0. So I have to add those. The absolute value of 1 is 1. The absolute value of negative 6 is 6, so it's 7. Now here's where our next spot comes into play, where we can show the difference between them. I see that we have a 2 in the x, so we're looking at the negative 9 and the negative 3. So I still want to find the absolute value of them, but now they have the same sign, meaning they're on the same side of 0. They're both negatives. So I'm going to subtract those two. And I have the absolute value of negative 9 is 9, and the absolute value of negative 3 is 3. So I subtract those. 9 minus 3 is 6. So that's a distance of 6. And we're going to prove this down below. So let's let's go down to 3 and take a look at some of these. And I'll actually show these to you by jumping on a coordinate plane. Okay, so let's start with BC. And I see B is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So the first point is 5, 8. That's how I find it. I'd go across my x starting at the origin and then go up. So I had 5 to right here, and then I counted 8 up. So 5, 8. That's where I got my 5, 8. Just wanted to point that out. So that's my first point. And then I got to look for C, which is over 1, 2, 3, 4, 5. And it's up 1, 2, 3, 4, 5. So now I'm going to prove this by looking first, and then I'll show you how to count these up. So I see that they both share a x of 5, so I have an 8 and a 5 that they don't share. And I need to find my absolute values of those. Now looking back up, we said same side of 0, meaning are they the same sign? Are they negatives or are they positives? And when we look at the coordinate plane, are they crossing over an axis line? Meaning, are they crossing the x or the y? No, they're both in the same quadrant. So if they cross to a new quadrant, that's really what we're saying. So if they have the same sign, we subtract, and the absolute value of 8 is 8, and the absolute value of 5 is 5. So if I have 8 minus 5, I have 3. Now how can I check this? Well, I'm going to zoom in and show you. So we're looking at the distance here, so I can actually jump. 1, 2, 3. So I know that the distance is 3, and there's my proof for it right there. Let's try one more. Let's try CD, because I already know C. It's 5, 5, because I just used it up above. And let's do D. I'm starting at the origin. I got negative 1, negative 2. And then I'm going up 1, 2, 3, 4, 5. So I see that they share the y coordinate, or the 5s. So I have my two other ones. And I'll do this in blue so you can see that. I have a 5 and a negative 2. And I'm still using absolute values. Now, from D to C, I'm crossing an axis, means they're on opposite sides of 0. One is a positive, one is a negative. So they have opposite signs. So I have to add the two. So really what it boils down to is the sign of the two numbers. If they're the same sign, you subtract. If they're opposite signs or different signs, you add them. So I have a 5, because absolute value of 5 is 5. Absolute value of negative 2 is 2. I add them, and I get 7. That's my distance. Now, we're going to zoom in again, and I'm going to count this to show you. And I'll use a different color. And here we go. So I'm starting at D, and I got 1, 2, 3, 4, 5, 6, 7. And was that what we had over here? Yes, it is. So that's how you'll solve these ones out in terms of finding the point and then the distance. And the proof is just the absolute value. And again, we have our statements right here that kind of help us out with finding those proofs. Okay, let's take a look at page 2. Now we have a similar thing here on page 2, where we're going to have to find some different line segments and find the distance and then prove them. So it's very similar to what we just did. All of these are going to be either horizontal or vertical, so it's the same thing. You just have to identify where the point is and name the point. So that's for 4. It's very similar to what we just did. Now let's take a look at 5 and 6. 5 says name 2 points with in different quadrants that form a vertical line segment that is 8 units in length. So I'm going to model this on the coordinate plane we have above using purple. So we have to do a vertical line segment that is 8 units, and it has to be in different quadrants. So I know that they're going to share the same x coordinate, meaning the first coordinate. So I'm going to pick 2. Meaning, if I zoom in here, I'm going on this line right here because that's 1, 2. Now I need something. I'm going to pick one up above. So 2, 1, 2, 3. Let's do 2, 3 for our first one. Now my other one, I need to be able to cross into a different quadrant, and it's got to be vertical. So I'm going down. I'm starting up at this 1, 2, 3, and I got 1, 2, 3, 4, 5, 6, 7, 8. And the reason why I'm counting down 8 is because I have to have 8 units in length. So what's my point going to be? I have 1, 2, which is right there, and then I have 1, 2, 3, 4, 5. So 2, comma, negative 5. And the reason why I'm negative is I'm going down below the x. So that's one possibility. The big thing you want to make sure of is that there's a distance of 5 between, or a distance of 8 between your 2 y coordinates. Your x coordinates, which is the first one, need to be the same. So you could do any number for your x coordinate. It could be negative 15 or positive 27. But they both have to be the same for the x. The y, one needs to be a positive, one needs to be a negative, and they need to be 8 jumps or 8 in distance. So when you add the absolute values, you need to be able to get 8. And I'll show you the absolute value piece. I know the absolute value of 3 is 3. And the absolute value of negative 5 is 5, and that's where my 8 units comes from. Because they're different signs, it means that I'm going to add them. So that's what you'll be doing for the next problem. They need to be in the same quadrant, and they form a horizontal line. So if they form a horizontal line, it means that the y's are going to be the same. So I'm going to pick something for my y, just a random number. So 4 in the y. Now I need to be in the same quadrant, meaning when I do my absolute values, I'm going to subtract them. And it needs to be 5. So if I do, I know 6 minus 1 gets me 5. And the absolute value of 6 is 6, and the absolute value of 1 is 1, and that gets me 5. So if I went up and plotted it up above on my coordinate plane, I could see that if I go over 6 and do 4, and go over 1 and do 4, I'm going to be on the same line. And I'll show you that one real quick. 6, 4, and 1, 4. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That's my first one. That's 6, 4. And now I have 1, 1, 2, 3, 4. 1, 4. Same quadrant, and now 1, 2, 3, 4, 5 jumps, or a distance of 5, which is what I needed right here. Hope this helps. Thanks for watching and good luck on your problem set.